On this episode of the podcast, I have with me Shantana Tully. She's the head of data at Upsolver. We're going to be talking about data design strategies and mainly around data lakehouses. A lot of projects are becoming more complex, complicated. So to require a more advanced data solution, we're going to need some different underlying structures, and we're going to hear all about that. I'm super excited. Shantana, thanks for being on the show.
Thank you so much for having me, Amir.
Absolutely. Before we start, if you could tell everyone, what does Upsolver do?
So Upsolver is a data movement solution, and we also have a shared storage product based on the Lakehouse. So we help ingest data from operational sources, typically, like databases, streams, etc. The data that's usually a very high volume or very high scale or being created quickly. We help ingest that into a data lake, a data warehouse. And if you so choose, you can ingest it into Upsolver's shared storage lakehouse, which again uses Iceberg as the open table format. And we do a bunch of quality constraints on the data, some automatic, some custom declared. And you do all of this, you author your pipelines in SQL. You can, if you choose, use the Python SDK, but that is also essentially a wraparound SQL. So the idea is simplicity. You sort of just think about how you want your data to be transformed and where it's coming from and where it's going to, and we sort of handle everything else. So it's like a Spark replacement that's much easier to use without the Py4j errors.
All right, so it's a great topic. It's definitely in your wheelhouse, and I'm excited. I mean, I guess to tee this up and kind of talk about it at a high level first. So we are seeing the concept of wanting to do more advanced data projects on top of data. Everyone has wanted to do more stuff with data. I have been in data for a long time. It's been a minute, but even during my time, everyone wanted to do more with data, and nothing's changed. We're trying to just do it with advanced capabilities and push the boundaries. As you're kind of looking at the movement to wanting to actually implement even more complicated and complex projects and some of the data design strategies that you need, maybe talk to us a little bit about the challenges if you don't have the right underlying structures in place.
So I've worked in sort of more product-facing data science, which is to say, like the working on the ML that actually was the product that end users were using. And I've also worked on analytics teams where the purpose was sort of understanding and providing the business an understanding of how things were going. And it's almost like, of course, there's like more AI as a product, which maybe is another step from ML as a product. But that's roughly think of that as the range of sort of data use cases that we have been thinking about, that we've been able to come up with. And the data infrastructure and data architecture that's set up is really core to whatever the use case. So it's almost like the layer of activation or usage is less relevant than the underlying, like how usable is the data, how accessible is the data. And I mean, this is sort of towing the line of, I've seen these memes that I absolutely hate where, the data engineer is holding back a train that's coming, at really high speed towards the data scientist. And so like, it's this idea of, sheltering. That's really not what I mean. It's all holistic, right? So starting from where the data is coming from, how do I efficiently extract it, load it? What can I do as far as quality enforcements upstream versus downstream? Like, everything has to be thought of at the same time, and all the way down to, okay, what is the use case? What are my end users going to see? What are my maybe internal users going to see? So like nothing can live in isolation. You can't be like, oh yeah, let me just collect all my business data and put it, dump it over here in an S3 bucket and, I've somehow leveraged data in my business. No, like that's not how it works. So you have to think about the use case, and based on that, you have to sort of pull in the relevant data and architect it in the right way. So, and that's where, data modeling comes in. especially when you think about analytics use cases. So you're sort of trying to represent the different entities in your business that you care about using the data that you've been able to gather, and sort of understanding the relationship between the different data points. And similarly with an ML use case, right, you have to think about, okay, what am I serving? What format does the data have to be in order for my ML model to make a prediction on it, and to train on it and all of that. And that's not going to look the same. That architecture, you don't need a data model for that. You don't need the entities. You just need the data to be vectorized on a representation that the ML model will understand. Of course, you know all this. But the idea, the thread there is that you have to think about it holistically based on the use case, and that's going to dictate and determine what the infrastructure is and what the data model is, or what the data architecture is. So when you talk about adding additional projects or going on to more advanced projects, however we define that, your sort of infrastructure and architecture have to evolve with that. And the trend that I think is like inevitable is, even if you started with a relatively narrow set of analytics questions that you wanted to answer with your business or about your business, most people want to go into finding some sort of application for generative AI, some sort of integration of LLMs into their products. I think that adding in more projects is pretty inevitable. I mean, it's not always well advised, right? Sometimes really all you need to know is sort of, what your inventory is and what your supply chain is looking like and so on and so forth. But it's sort of the reality is that we constantly have more projects or kinds of things we want to do with data. We constantly think of new data sources that might be relevant, all for good reason. And whenever you bring these new use cases and data sources in, you have to think about how that extends the existing architecture and infrastructure, and whether you need to move to some other form of organization, like whether your current model will scale. So, for example, I know I'm sort of talking at length here, but for example, right, if you have a data warehouse with a strict data model and you want to add an ML use case, like that might not be the best setup, right? You might want to add in or start using a data lake instead, or in addition to, right? So then you have your data in the warehouse, and sort of the same data is in the lake, just in a different format. It's more like machine accessible rather than human readable, and that's sort of suboptimal. So I think we're at a point now, like broadly speaking, where we've done that. We've run the gambit from databases, data warehouses, data lakes, and we're coming out to this point of, what if I had it together? What if I could have a data model, but that sort of sits as a layer of abstraction on top, right? But the underlying data sort of setup infrastructure is more fluid, is more storage optimized, and compute optimized, and all of these things sort of lead you to. And then you think about, okay, what if I want acidity in my transactions of this, supposed lake/warehouse combination, aka Lakehouse? So you bring the sort of the best of all the worlds there, and you bring together, and that's how I think we end up with the Lakehouse where we're at today.
And actually, I think it's a great kind of explanation as to the strategy and the use case and some of the purposes behind it. I guess as we're seeing the discussion around data and implementations of more advanced use cases, there are companies at different stages of data maturity. We have companies, I talked to some of the leaders, that they're still working with on-premise SQL servers, and they're still in the journey to the cloud. There's some that are really at the cutting edge. They have their own ML engineers, and they're focusing on delivering those advanced solutions. I guess when you're looking at the right solution, right, and if you're looking at where you're at along that maturity curve, if you're a little bit further behind, does it make sense to try to jump ahead and catch up, or is there a necessary, maturity process and path that you should be following to kind of be able to build the more complex solutions?
Yes and no, right? I'll give the safe answer of yes and no. The question is, like, should you have to reinvent the wheel? Kind of, right? should you have to make the same mistakes or to go through the same sort of set of paradigms to ultimately get to where you might want to end up? And the answer is still like can be no for a certain like or can be yes for certain businesses, as you said, because the end product, the end state of data at a given business might not be like a lake house that's, suited for a number of different use cases. So I'm not going to say, yes, we should all think about future proofing ourselves and, go to this architecture. You have to think of it as it pertains to your particular business and what you're looking to do. But I will say more broadly speaking, if you are like when the term the data lake was coined, right? We did see a lot of folks move towards to the data lake, and then cloud warehouses kind of upped their game, and so that became a. So I think we're very prone to doing these like mass migrations from technology to technology, and it's honestly a difficult question of like how do you think about the future? How do you think about do I need this? How do you make those considerations? Now, you don't really lose anything by going to a lakehouse architecture. So that's one big point in favor, which is to say it's still like the lakehouse architecture basically, especially with the three main players right now in the market, the open table formats sit on top of your traditional open data formats like Parquet, Avro, whatever else you have. So it kind of retains a degree of portability or portability to a very high degree, actually. So if you did decide that, okay, I don't actually want my data to conform to this table format, not only can you switch to a different table format, you can also just say, okay, I don't want a table. I just want a regular Hive meta store on top of my Parquet files. So go back to your traditional data lake kind of infrastructure and without losing anything. So that's another thing that I really love about lake houses is they're essentially powered by this table management layer, table format specification, and that's really all they are. So Apache Iceberg, which is what Absolver is close to, Apache Hoodie, Delta Lake, all of these essentially it's just a specification of how to organize your metadata and your manifests and your data. Beyond that, it's not telling you, okay, you have to do things a certain way. It's more like if you organize your data in this way, then we can guarantee that you can do these transactions in an ACID compliant way, or you have these things that you get. So if you're sort of starting to think today, I want to do inventory management for my retail company, brick and mortar or e-commerce, what infrastructure should I set up? I mean, there are some things that are sort of like the basics, right? Like you need somewhere to store your data. It's probably going to be cloud storage. Maybe it's not even, maybe it's like on-prem storage. That's fine too. What format should I put them in? Parquet is pretty standard. Like there's no, it's not like that's the thing. Like we come to these standards after a lot of, back and forth and trial and testing. So embrace the standards. And then from there, okay, how do I organize my data? How do I store the metadata? There's really like not a lot of wrong answers, but the pains that we've felt. So for example, I mentioned Spark earlier and, working with Hive Metastore, like there are inefficiencies and there are pain points that we've sort of discovered over the years. So at least reading up on those trade-offs, right? Like how does it work? And what are the shortcomings that have caused people to come up with alternatives, and people from like large tech forward companies that have built these new solutions, right? What's the motivation? And I think ultimately, like that's how we advance, right? Like Spark was a great solution, 5 years ago, and then we sort of realized, its shortcomings. So.
Yeah, no, and I guess what's interesting is, as you're kind of talking about the maturity side of and some of the, you can take a quantum leap forward. You don't have to necessarily make the same mistakes. You can look at best practices. I was actually thinking about some of the challenges that might go along with that, because your staff might not really be well versed in some of the the more modern stack of data technologies, which to me are aligning more towards a software engineering mindset than what data was at any point before it. I guess if you're looking at the skill sets, and again, I guess it's just an interesting maybe discussion around companies, because I think there can be a fair number of companies that, while we hear a lot about cloud and the process of modernization, they're a lot further behind. And as we're trying to catch up, the skill gap required to be modern is going to be a big step forward for a lot of these companies. I guess if you're looking at a place where you're not progressive and you're not up onto the latest standards of technologies, is there a good way of trying to modernize and trying to kind of move forward versus, obviously without, gutting your whole staff, without having to completely bring in new people? How do you have you come across that situation at Upsolver where you've worked with a client that potentially is trying to modernize and they're trying to figure out how to do it with existing staff?
Yes, we have, and that's where like being a sort of turnkey solution, where you just have to think about the data transformations, and not what's happening underneath is really helpful. It's really, I mean, relatively easy to show the value proposition of a product that's like that, and you sort of come in, okay, you're working in your SQL Server or your Postgres, database, and like with a couple of quick connections, you can get your data out of it or replicated or migrated. So we have come across sort of clients that are more working in a different stack, in an earlier stack, and that's been a big helpful thing. But I will say that from the point of view of a business that is, for lack of a better word, sort of lagging a bit in terms of adopting technology. And let me couch that by also saying you can also be like too far forward, right? Like you can be visionary and try out a bunch of new technology, but like it's sort of all like just for the sake of trying it out. But from the perspective of a company that's maybe further along, I wouldn't really think of it as do I gut my staff and try to find folks with the skill set. I actually, and maybe this is, unpopular opinion, but I happen to think that tools are relatively easy to pick up, all told. So the underlying skills of knowing how to work with data, if you're on the data science side, data analysis side, like the stat skills. If you're more on the pipeline side, the cron, how does cron work? Like, do you have experience in that? Okay, then you can, sort of build off of that to work in Airflow or the next generation of orchestrators, that kind of stuff. So I think for me, if there is sufficient alignment in like leadership and like middle management, that this is something that we have to do for the business, it's going to pay dividends in the long term at least, and probably in the short term as well, to migrate to the cloud, to migrate to like a more modern stack. I think that should be sufficient, with a little bit of grace around, okay, let's make sure we're training our employees and finding that education to go from there. There are a ton of resources, right? I mean, there's good and bad, and so you do have to be careful about what you take from the internet. But I do think that the fact that we are pretty comfortable in tech with learning publicly and sharing our learnings publicly, right? I get a lot of value from reading blog posts from the tech forward companies that are, sort of talking about, okay, this is a problem we came across. These are the solutions we consider. Blog posts and talks. These are the solutions we considered. This is ultimately what we went with because of XYZ reason. Like those things, like it's someone else is doing the hard work for you. They're doing the learning and sharing, and so you can take from that and build on that. So. Yeah, I mean, I don't see it as a huge hurdle to sort of modernize your stack. And then final thing I want to add here is, let's be clear that modernizing your stack is not the same thing as buying into the modern data stack. So I don't want to get into the whole debate of whether the modern data stack is a zombie or not. But just gonna say, like, it's that's just a marketing thing. The few companies wrote in on, and there are some shared themes there, right? A little bit of ease of use, some degree of abstraction, and stuff, but you can get all of that elsewhere as well from other companies that are also modern, but maybe not, part of that cohort of the modern data stack companies. So yeah, just, I don't mean that label at all whatsoever. I just mean, just thinking about the next generation, the next iteration of these tooling.
Absolutely. I guess I was going to ask you about companies that are on the other side that are working on bleeding edge, but I was going to ask you before we get there. I guess if you kind of look back at data technologies, we did go through a period where everything was really difficult to tons of tools. Once we hit a little bit of maturity, tons of tools came in. We've seen a shift again to new technologies. We won't call them modern, just other technology. We saw it becoming very much less tool driven, but now we are seeing a lot of tools. Like we are seeing tools come out to help facilitate the non-software engineering approach to the modern data stack, right? Whereas before, if you couldn't write the code, you're really left behind. Like it was a challenge. Are you going to see, well, to a degree, not completely, but are we going to see more and more tools to help companies deploy these solutions easier until obviously the next shift? But for a while, are we going to continue to see that?
Yeah, I think for me the answer is a pretty solid yes. I think there's a certain degree, like I'm not entirely sure what the mentality was around it, but like just sort of looking at it from the outside or maybe in retrospect, I think there's a degree of like egotism in wanting deeper, like more lower level tools when you don't need them. So I mean, I will admit that I've suffered from this as well, right? Okay, I can do this in Spark. I can do this in, I don't know, some low level tool, like I coded in C++ for like 5 years, right? So like so why I'm gonna do it, right? Like sort of digging in my heels, be like, I can do this in this sort of high fluffy software engineering way. So that's what I'm going to do. And if you can't do it, then you're different. You're a low code person. And so, but I think it's a really unhealthy mentality to have, and I think we've had it in our field. So going from there, then as you said, there's been at least, I don't know what time frame you'd put on it, but I'd say maybe a year or two. We've sort of had more of these configuration-based sort of declarative frameworks and stuff. And I think partly because the more tech-forward companies were also going in that direction, in fact, because they have the resource advantage, right? So they can have a dedicated platform team, infrastructure team, integrations team, and then the folks that are implementing the use cases and delivering the ultimate thing of value, the final piece, they don't have to be exposed to all of that. So they were, internally they were creating these layers of abstraction to make it really easy for the product data scientist or however you might classify a set of people to actually deliver the value. So, and then out of there, and it became pretty clear, I think, that a declarative framework is better. Like you don't want to have to write everything from scratch. If you can, give me as a parameter, this is sort of so like the what kind of cluster I should spin up, or what sort of packages I need to install in a given pod or virtual environment. That's better than having to write it from scratch every time, because there is a lot of repeated code as well, repeated pieces. So like with Docker, right? Like you sort of package it and standardize it so that it's easy for someone to then self-serve. So I think so. I've kind of forgotten at this point what exactly your question was, but I think we've made that progress, even though we were sort of working against ourselves there a little bit. And I think today and going forward, we are going to see a better marriage or better acceptance, maybe, or integration of tools that are lower code, or no code. As long as, like, I think we still have to do our due diligence and check that the things that are being abstracted away are being implemented well, right? And I think that is still a profession where you want to sort of understand what's happening under the hood, and you want to make sure, okay, the Absolver is claiming to do all of this like heavy lifting, figuring out how my compute should scale, et cetera, et cetera. Is it actually doing a good job, right? I think people should consider that at the time of buy build decision, is like, but then when you choose to buy that tool, you're buying it for the fact that it makes it easy for your users to do the thing they need to do. And instead of having a team to maintain this platform that was in charge of doing all these things, you have a tool that you've sort of vetted that it's good at doing that abstraction.
Actually, you did answer the question. I think you provided a lot of depth to it as well. And I guess the final question, just out of curiosity, obviously we've talked about companies moving forward with their stack. And you mentioned obviously some of the dangers of companies being a little bit too far forward. I guess when you're looking at this push to, bring in more advanced, like it could be machine learning, could be Gen AI, could be another form of AI, could be whatever at this point. Everyone has this feeling that they need to be pushing. What are some of the risks of companies trying to push? Obviously, there's a lot of solutions, a lot of new solutions, a lot of untested solutions, but it seems like people are looking to find competitive advantages, and first mover advantage has become very important. At least the illusion of first mover advantage is very important. Are you seeing some potential risks or areas that companies could find themselves in trouble with?
I am, but I will also say, like, I don't know. Partly I'm very excited about this new phase because I want to see what happens without coming up with a lot of predictions. The one thing that I'll say is like the intent is very important, right? If you are sort of jumping on a trend because you have FOMO, right, fear of missing out, that's not the best motivator. This is also, like when I went to grad school, because I went to grad school, some folks, sometimes I'll talk to folks who are like trying to make the decision of should I go to grad school? And the one thing I say is like, what's your motivation? You can't get a PhD because you want a PhD, right? You have to want to do the research and you have to enjoy the research. That's a sort of a total random tangent. But the point is that like why you want to jump on this train is very important. Really not convinced that for a vast majority of companies there is anything to add to their product from the Gen AI movement. And so like, are you doing it to like please your board? Are you doing it to like, be part of the sexy cohort of companies? Those are questions that you need to be asking. With that said, I think it is absolutely, revolutionary, like not revolutionary, but like where we are today is super impressive to see in terms of large generative models, language and CV and otherwise. And there's going to be like, we are going to use this technology in amazing ways in the next 10, 20 years. So this is not me foo-fooing the technology. It's more, I think there's going to be bad ideas in the next 2, 3, 5 years that are going to fizzle out before we sort of figure out those, like the things that endure. And yeah.
I like it. I know we covered a lot of different areas. We've covered forward thinking, backward thinking, current thinking. I mean, I appreciate it. I could apparently throw any question at you, and you've got thoughts, which I really like. Obviously, we didn't get deep in any one particular area. So if somebody does want to reach out to you to kind of talk to you about one of the areas that we've covered, what is a good way of touching base with you?
I'm pretty easy to find on LinkedIn. I will occasionally rant on there. So please, find me on LinkedIn, connect, follow as you wish. I work at Absolver, so you can also find my work through there.
Okay, awesome. We'll include some show those links in some of the show notes. But again, thanks for being on the show. Thanks for sharing. I appreciate it.
This was so much fun. Thank you.
Awesome. That's it for the episode. Be back again, different guest, different topic. Until then, two things. It's a great episode. I know we didn't get super deep in any one particular area, but we really did cover a breadth of, I guess, how you deal with some of the challenges around taking advantage of data and moving towards advanced solutions, which could be a lot of things for different companies. And that's why I think we kind of went a little bit more broadly than I intended, but I really love the conversation. So I appreciate that. So share this episode with somebody else who might find value in it. I think it's been a great show. And please let me know how we're doing. Like, subscribe, comment, leave me a review. I appreciate it. Thank you. Until next time, and goodbye.